Hello, today we will talk about the probability of winning the lottery. We will have a selection of 51 numbers, and to win the grand prize is matching all six numbers. So we're looking at how people are increasing their chances of winning and the probability of those things happening. So the first question, we are looking at just the probability of winning the grand prize, which is matching all six numbers. And this is a discrete distribution because we can define it finitely. We can get the probability of winning each combination. So I use hypergeometric distribution because those numbers will be drawn but will not be repeated within the winning number set. So as we calculate the probability using hypergeometric distribution, we can see the graph shows that the number of matches decrease um, significantly. So there's a higher probability that there will be no numbers matched, and it continues to decrease and exponentially smaller here at six matches. It's extremely small. So as we go on to question number two, Alexandria buys one ticket every 24 hours for 365 days over 80 years at $5. So we're looking at what's the chances of her winning the grand prize at least once in her life and how much money would she have spent. So over the course of 80 years, she would have spent $146,000 on tickets, and she has a better chance of winning at 1,000th of a percent chance of winning at least once in her life. As we calculated, it is higher than just the typical person buying just one ticket. So she did increase her chances of winning as well. And we just did that by calculating the total outcomes and getting the probability of winning per ticket and then how much money she would win. I mean, would she have paid over the course of 80 years and the probability of never winning. And then we get that probability of her winning at least once. As we go to question three is about Amir, and he is trying to figure out how many friends he needs to win if they buy one ticket each for the week's drawing. So we're looking at different probability levels or epsilon of them winning and how many friends, the minimum number of friends he will need for each of those probabilities. So as we look here, to get the smallest probability, he would need around 181 friends. And to get a 50% chance of winning, he will need over 12 million friends to buy one ticket per week. And as you can see here, calculating how we would get those probabilities and the minimum number, calculating the minimum number of friends needed. And here we use the logarithm to show, get that minimum number as well. And you'll see it as I get to the graph at some point, how it exponentially increases. So as the chances of them winning based on one ticket per week increases, the number of friends he will need drastically increases exponentially. Question number four is saying if he gathered his friends and he at 50% probability, if he did not want to increase the number of friends, how can they increase their chances of winning? This will be by them sitting down, compare their numbers, and pulling unique numbers. So making sure that there's no overlap and they're all getting different numbers. So that's what we calculated here. Again, it's like 12 million friends. So I kind of had to stop it from running, but unique numbers, unique data sets or unique winning number combinations would be how they would increase their probability of winning without increasing the number of people used. And lastly, we look at if the lottery put in a consolation prize, would it increase sales? If they chose three numbers and out of six, would they increase sales by doing this? So what I found was in doing that, at different price points, the expected value of those consolation prizes does increase. But if we're taking the assumption that they're $5 per ticket, The consolation prize would have to be at least $317 or less for the lottery to make a profit. So the sales may increase for people who get in this mid-range of $100 to $500 consolation prize just based on eagerness and the perceived value. But if we're going to do a profit for the lottery, making that consolation prize between around $300 or a little less than $317 would still give a profit. So at $300, that would be, for example, 27-cent profit per consolation prize paid. So it could increase sales. Of course, if you put more consolation prizes out there, you could get more sales. However, that would not be beneficial for the lottery because it would then have a loss. So that's our look at probability of winning the lottery.